Hi everyone, my name is Alif. I would like to talk about strategic case Powering Tāmaki Makaurau Charging the Future. According to Energy Efficiency and Conservation Authority, Auckland currently has 445 public EV chargers. However, the rollout is still fragmented and uneven across the region. At the same time, Auckland is growing quickly. According to the Regional Land Transport Plan, more than 220,000 new residents are expected by 2034 on top of the 1.7 million people living there today. This means the demand for EV charging infrastructure will continue to increase. Auckland Council has also committed to reducing transport emission by 64% through the Transport Emission Reduction Pathway. This is ambitious target, but the current pace of delivery is still not enough to achieve it. Business as usual is slow and limited by funding. It cannot close the gap. If no action is taken, EV adoption might slow down, fossil fuel dependency might continue, and the gap between Auckland climate target and actual delivery will become even wider. Therefore, the case for change is not just important, it is urgent. This investment is built around four objectives. First, strengthening Auckland transition to low-emission transport. Infrastructure barriers still limit EV uptake, so Auckland charging network must become more ready, practical, and accessible for all users. Second, closing the access gap. Today, charging infrastructure is mainly concentrated in commercial and high-demand areas. However, low-income suburbs, community centers, and underserved areas also need equal access for Aucklanders. Third, improving usability. Having charger installed does not automatically mean people will use them. Charging must be simple, reliable, and convenient so users feel confident and comfortable using the network. The last one, improving operational reliability. A charger that is physically available but often offline does not solve the problem. Therefore, the objective focus on improving charger availability, reducing downtime, providing faster response when technical disruption occurs. To achieve Auckland 2030 EV target, several critical factors must be addressed. First, strategic fit and business needs. The project supports Auckland transition to low-emission transport. As EV use continue to grow, Auckland needs reliable, accessible, and strategically located charging infrastructure. Second, value for money. The project focuses on high-demand area, so the chargers are more likely to be used regularly. This helps generate revenue to support operation, maintenance, and investment costs over time. Third, commercial and supplier capacity. The project requires capable supplier, investor, and network operator. The chosen scheme must support project development. 4. Financial affordability. The project is designed with realistic funding limit. Main costs including equipment, installation, grid upgrade, operation, and maintenance have already been considered. The last one, achievability and management. The project achievability depends on adequate grid capacity, realistic delivery timelines, support government policy, and Auckland commitment to reduce emissions. In running this project, there are six strategic risks that must be considered. First, EV adoption growth remain unpredictable, risking low charge utilization and delay emission target. Second, limited grid capacity, constant variable location, and increased infrastructure costs. Third, fast charging requires significantly higher capital than alternative, limiting deployment scales. 4. Government policy change on EV implementation can erode investor confidence. 5. Customer preference for home charging poses a sustained utilization risk. The last one, limited vendor capability might compromise delivery timelines and implementation quality. So, to ensure this investment remains viable despite this uncertainty, each risk is addressed through a structured economic, commercial, financial, and management case approach.
The economic case demonstrates how Auckland Council can deliver the strongest public value from investment in a region-wide EV charging network. It ensures the preferred option is strategically aligned, regulatory readiness, and financially realistic. We evaluated 5 dimensions of choice: service scale, technology, delivery model, rollout timing, and funding approach. Across each dimension, we went through options from due minimum to maximum intervention scenarios to understand what is viable and affordable. Several options were excluded at an early stage of evaluation. For example, DC-only network were removed due to their high cost at a region-wide scale. Standard, non-smart chargers were also excluded as they would not comply with upcoming regulatory requirements. Vehicle-to-grid technology was excluded due to its current immaturity for large-scale deployment. This filtering process ensured that only realistic, policy-aligned, and implementable options progress to further analysis. This left us with below most viable approaches. The status quo, do nothing, as our baseline for comparison. Option 2 is a region-wide smart AC-DC mix network, delivered via public-private partnership model. As for option 3, it's the same setting as option 2, but fully council-owned and reliant solely on government grants. The options deliver significantly economic value, like EECM modeling suggests that smart charging could save New Zealand approximately $4 billion in avoided grid upgrades by 2050. For the average Auckland family, switching to electric could slash energy costs by up to $3,000 per year, while smart chargers have high upfront cost for building. These are heavily outweighed by massive long-term savings and improved regional productivity. It also has other intangible non-monetary benefits, including like using dynamic load management. It's the smart chargers function to ensure a better user experience. It also signals a visible commitment to decarbonization, positioning the council as a sustainability leader. Moreover, while we drop V2G for now, the infrastructure we are building today is what makes vehicle to whatever possible tomorrow. When analyzed and stress-tested, option 2 demonstrates strong financial resilience. By sharing risk with our private partners, the model creates a financial buffer that supports project delivery under adverse conditions like 70% reduction in government funding or 30% increase in capital cost. The proposal still remains viable. Our analysis demonstrates that a region-wide mixed AC-DC charging network comprising a total of 70 smart chargers and delivered through a co-investment partnership model provides the highest public value. The proposed approach achieves a balanced outcome across cost, equity, and performance considerations, while also aligning with Auckland's long-term transport decarbonization objectives.
Now I will explain about the commercial case. For the procurement strategy to deliver the preferred option AP2, we have 5 phases. Starting for the first page is the market mapping and stakeholder engagement in Quarter 1. During this stage, the Auckland Council and Auckland Transport engage with all of the stakeholders such as the EV charging operator, electricity distribution to discuss about this project. Then the second phase is procurement planning and requirement finalization in Quarter 2. At this stage, the evaluation framework is also approved to ensure transparent and consistent vendor assessment. Then continue in the third phase is tendering process in Quarter 3 to identify the most competitive and technical deliverable partner. And then the phase 4 is the due diligence and commercial evaluation in Quarter 4 using the financial visibility and compliance with the requirement are assessed before the negotiation. And then the last part in the phase 5 in Quarter 1 2027, the project enter contract negotiation and the partner sign. Okay, the project also identified 3 procurement-related risks. Firstly, charger procurement and supply chain delays are allocated to the private operator as they are closer to supplier and responsible for time delivery. The second one, increasing hardware costs are also allocated to the private operator because they can better manage equipment sourcing and the price fluctuation. And the last one, the public funding shortfall is shared between the Auckland Council and private investor. So it should be make a good agreement within their stakeholder. For the payment mechanism, 90% of the contract value is paid through milestone-based payment during the 3 years rollout. After each charger trace is installed, task, connection, and operation, the remaining 10% is retained until the full 70 charger network commission and meet agreed service requirement. This is to ensure the payment is linked to the actual delivery and the performance of the stakeholder or the vendor. Then the final section is about the contract because we using the PPP scheme model. The project use this consistent agreement where the private partner finance, build and operate the charging network under the long-term contract with the Auckland Council. The contract terms is 15 years, consisting of the 3 years for the rollout period and 12 years for the operational period, aligned with the expected set life of the smart charging infrastructure. In terms of the ownership, the infrastructure assets remain owned by the Auckland Council, while the private partner manage the operation during the concession period. The contract also include the flexibility through the limited scope variation, annual CPI index adjustment, and allocation for the delay, defect, and non-compliance. And the last one for the termination clause and performance obligation are included to ensure the accountability and protect the public investment throughout the contract period.
Next, I will present the financial case for APO2. This part focuses on funding, affordability, and the costs that remain on the public side. The financial case looks at APO2 from a funding point of view. It focuses on the cost that remains on the public side rather than the full project total. So the key issue here is not which option is preferred, but how the cost is structured, how funding is shared, and what financial responsibility stays with Auckland Council. This slide shows how the public side cost is organized. The capex basis is $3.1 million, and the public side capex is $1.55 million under the 50-50 PPP split. Most capex sits in grid, civil works, electrical connection, and charger hardware. Public side OpEx is $1.89 million, mainly in contract management, compliance support, and software support. So the total public side exposure is $3.44 million. This slide shows the funding structure on the APO2. The preferred structure relies mainly on public contribution from Auckland Council and Auckland Transport, together with private PPP capital, with each side contributing about $1.55 million. Any support from the New Zealand Transport Agency, National Land Transport Fund, or from Crown or loan support is treated as optional at this stage rather than confirmed. So, the main funding structure is clear, while external support remains conditional. This slide shows the public side cost path on the APO2. The first 3 years capture the main rollout cost. After rollout, the cost drops to $90,000 in 2030 to 2031 and then remains at $19,000 per year beyond that. So the main public side cost happens upfront while the ongoing public side OpEx stays relatively low. This slide shows the residual public side cost on the APO2. Most of the public side capital cost sits in the first 3 years, mainly through site, grid, civil works, and charger-related technology. After rollout, the public side still retains a smaller ongoing cost, including personnel and non-personnel support. This cost mainly related to oversight, compliance, software support, reporting, and contract management. An important point is that the beyond amount means $19,000 per year, not $19,000 in total.
So I will be presenting the management case for Auckland's EV charging network, option AP02. This is a public-private partnership to deliver 70 smart chargers across Auckland in just 36 months. Delivery is split into 4 clear phases. Phase 0 is mobilization. We set up the PMO and finalize the PPP agreement in the first 6 months. Phase 1 installs 30 AC chargers at city and suburban hubs by month 18. Phase 2 rolls out 40 DC chargers along State Highway 1 corridors by month 30. Then phase 3 hands full operational control to Auckland Transport by month 36. This uh, this phase approach is proven. It mirrors the UFB broadband rollout model. Governance runs across three tiers. At the top, the Auckland Council governing body holds final approval. The senior responsible owner manages day-to-day delivery. Operationally, a project control group meeting fortnightly across council, the Auckland Transport and the PPP operator under an independent assurance panel, including NZ Treasure and NZTA, reviews every major gateway. The numbers are compelling. EP02 contributes to $4 billion in avoided national grid upgrade costs by 2050. Auckland households could save up to $3,000 a year in transport energy costs. By month 36, we target 70 chargers live, 97 uptime, and at least 60% of session happening off peak. Crucially, 30% of AC chargers will go into low-income equity zones, making this accessible for everyone. We have identified 5 key delivery risks: PPP default, consent delays, grid connection, cybersecurity, and cost overrun. Each has a clear owner and mitigation already in place, including performance bond and a 50% contingency budget. On engagement, we start with Maori and equity communities from day one and run a full public awareness campaign through to completion. In summary, structured delivery, strong governance, clear benefits, risk managed, AP02 is ready to go. And thank you.